Hi, everyone. My name is Danila Posevin. I am from Russia, from Moscow region. I'm from Reutov. I'm a teacher of Arduino, and I want to introduce you our lesson, dream lesson, Goldberg machine of simple Internet of Things. I suppose that everyone knows what is IoT or Internet of Things. And I suppose that everybody knows what is Goldberg machine. Goldberg machine is a very complex system, mechanical system, which produce simple action by very complex actions. And the idea of our lesson is creating a mixture of physical things and information control. What do I mean? I mean that we will control each part of Goldberg machine by some server which produce simple actions. What is the idea of our lesson? Let's compare. Usual Goldberg machine is a complex system. This is Goldberg machine, which is a system of many simple parts or simple actions. A simple actions goes here, simple action, and this action produce many actions between these simple things. And the system depends of architecture of this machine. And then we have some result, some simple result. So what do we want to do? The idea is very simple. This will be a set of many Goldberg machine all over the world. Many machines in many schools all over the world. So how it works? Suppose this is Russia. This is India. And here is, for example, Australia. And here is, for example, some other country. Yes, and here are some schools. And in each school, we have our own Goldberg machine, simple Goldberg machine, which makes some simple actions. Here is Goldberg machine 1, here is Goldberg machine 2. Let's make here index I because it is from India. And here is Goldberg machine from India N, and so on. In Russia, we have one Goldberg machine, for example, in Reutov. Here, Goldberg machine in, for example, Krasnodar. And here, for example, Goldberg machine from Magadan. For example, here is Goldberg machine from Delhi or from other country. So here is Sydney. And this is Australian Goldberg machine number 1. Here is Australian Goldberg machine number 2. Here, Australian Goldberg machine number N, and so on. Each machine must be controlled from some server, some personal server. Each school must start or up its own control server of simple Internet of Things. Here is, and so on. Each Goldberg machine has its own personal server. And for example, simple action goes from here. In this system, there are own simple actions. Then these actions transmits here. Here are some own actions, and so we can create very interesting Goldberg machine all over the world. One Goldberg machine produce its result and transmit it to Russia, and from Russia, a result transmits to Australia, and so on, all over the world. So here we will see a hybrid system, hybrid Goldberg machine. This machine will be, this machine must be forced by physics actions from physics life, but logic is controlled by electronic world from internet world. So this will be hybrid system. Let's consider one Goldberg machine of internet, of simple Internet of Things. So what do I mean? Let's see my demonstrations. I'm switching on my camera, and I want to show you smart boiler. What do I mean by saying smart boiler? Very simple boiler, and everybody saw it. We took this boiler from my grandma. This is Soviet boiler. Look at this. This is very old, and but we made it smart. What do I mean by smart? We took microcontroller. This is Node MCU microcontroller based on ESP8266 microcontroller. This is very cheap, and you can buy it in AliExpress. So then we took this relay shield. This is a Russian variant of relay shield, but this variant you can buy on AliExpress. So, or for example, in Amazon, or maybe on eBay. So, how it works? These microcontroller support Wi-Fi. You can see here an antenna. So we can connect this microcontroller to local area network. Let's consider this. It is very small and very cheap. I can't say how much does it cost in dollars, but I can say how much does it cost in rubles. It costs 200 rubles or 400 rubles. It depends of internet shop where you can buy it. So, for example, how we create a smart lamp. Look at this, please. Just a second. Here you see a simple lamp, which I took from my daughter. And then what did I do? I took that microcontroller, then look at this. And then I connected this microcontroller to a relay shield. Oh, something went wrong. I don't know, but it turned off. Why? Really, I don't know. something happened, but we will check it. I suppose that someone switched this simple Internet of Things from our IO control system. So what we constructed, here is another Internet of Things, clever thermometer. Here is very high, very good and very perfect thermometer, which can which can measure temperature very perfectly. So what can we do? We can control these simple things, simple boiler, simple lamp, simple thermometer from internet. And how can we do it? So I will show you the idea. The idea is very simple. For controlling this Internet of Things, we use special server. We use a Russian server, and this server is called iocontrol.ru. I suppose that it is no problem to use it from all over the world. And there are a lot of such systems, and you can use, for example, another cloud system to create this idea. But I show you our idea, and I will show you our system. So look at this, please. How it is constructed. Now you can see here three constants. One constant is called a boiler, second called lamp, and the third temperature. Here you see the name of dashboard. This is dashboard, which I can configure by myself. I need to log into the system and then create this dashboard. The name of dashboard is written in Russian, but I suppose that it is clear. So now I created a constant of boiler. Boiler can be in two states. One state is on, second state is off. Now we see that our boiler now is switched off. Okay, it must be switched off, because if it will be in on state, we would see a fire or something awful. But the second state of lamp is on. But look at this, lamp is switched off. I don't know why. I suppose that there is some bug, and we will try to fix this bug now. And I suppose that actually it will work at the end of the lesson. But now it doesn't want to work. So I will restart it. What I want to switch it on and off, and then we will see what happened. I think that it doesn't work. Maybe there is some problem with the lamp, but we will see. We will work with boiler. So what can they see? What can they see? We can see pressure, a temperature. Here is the temperature which we get from this thermometer. So I take it to my hand and let's see that the value of temperature begins to increase. If we wait a little bit more, we will see that the temperature here will be the temperature of my body. Here we can see, for example, a graph of how temperature increases. In this part, we see the rate of increasement. So let's go back and see what will happen. Then I free the thermometer. The temperature begins to is changing. So what will be happen when we take water, put here, and now I want to measure the temperature of this water. So let's see. We see that the temperature is changing very fast. And now I will do the following. Just a second. I take my smart boiler, put it to the water, and now we will start boiling, and we will try to see the dependence between the rate of boiling and temperature. So let's go. It will be very we must be very careful. So see that I'm turning on the boiler, and let's see what will happen. See here, and see to the please look at the rate of temperature. Here it begins to boil. Look to the water and look to the temperature. So we see how it increases. See, guys. I'm sorry, but lamp doesn't want to switch on. I don't know why. I suppose that there is problem with microcontroller. I suppose it is I broke it. So here we see the temperature is increases, and we see how it boils. Look at display of indicator of microcontroller which gets value of temperature. So let's stop of this process, because it will boil off. Look at this. The temperature in some time will stop to rise because I switched it off. Sorry, I switched off not boiler but the lamp. But now I switched off the exactly the boiler. So see, the increasement of temperature is completely stopped. So what do we want to do? We want to make a complex system which will work together, a complex system together with two Internet of Things. for example, with lamp and with boiler. So the idea very simple. Look at this. What do I want to do? I want to take a boiler. So this is picture of the boiler, which I showed you. Boiler in the water. Yes. So this is a relay shield. And here is a microcomputer node MCU. So it is connected via internet to our cloud server IO control. So here is a constant boiler. Here is a constant temperature. And here is constant lamp. Oh no, lamp doesn't work. Guys, I'm sorry, I don't know. I suppose that why it doesn't work. I suppose that there is a problem with a microcontroller. But now, or maybe in the lamp, because the lamp, the microcontroller seem to be work. I suppose that the problem in lamp, it is broken now. So relay shield have two states, on or off. So boiler has two values, 0 or 1. If constant equals to 0, then boiler is off. And if constant boiler equals 1, relay shield switches the boiler to on. So in the other hand, there is a thermometer. So it sends via microcontroller node MCU the value of temperature in this constant. So here is, for example, it equals, let's see the value of the temperature right now. Just a second. Let's look at this. Here. Oh, guys, something happened. Look at this. My lamp works. Oh, why? It works. Look at this. It switches off and it switches on. I just switched it and switched on. It's a magic, yeah. So it's good. I like this technique. So look at the temperature. Here is 78, approximately 75. So in our so now let's see our picture. Here is 75 degrees. So what do I want to do? I want to do the next thing. As our lamp is recovered, so we will do the following. For example, this is lamp. Lamp has the same relay shield connected to node MCU, and this connected to constant lamp. If lamp equals 0, lamp is switched or off, and if a constant lamp equals 1, the lamp is switched on. So what will we do? We will do the following. If temperature greater than 22 degrees, the boiler stops. It must be turned off. If temperature less than 22 degrees, boiler must be switched on, and the lamp must be switched on when the temperature is higher than 22 degrees. But what do we have in this system? We have one more microcontroller, node MC, which controls all of these parameters. So all of these simple internet things are dummy things. They have no logic. Logic is only here. This microcontroller has a role of server. These microcontrollers controls this simple Internet of Things. I mean, smart boiler. It controls smart thermometer, and this controls smart lamp. So in this picture, we see one simple Internet of Things machine Goldberg in one school. And my idea is that we all create such things all over the world. If you will like this idea, I will be glad to start this pilot project. So let's see how the system works. Now I take another tank of water. So now I take my thermometer, put here. Now I take, then I take, oh sorry, I take my boiler, put here. So look at this. I suppose that now everything will be okay. So lamp is working. It is switched on. Then thermometer is working. Everything is working. My system is working too. So I suppose we are ready to start this system. So now please see to the camera and see, look to the panel. But first of all, I want to compile my sketch, Arduino sketch, for controller, for server controller. Please look at this. This is the sketch of this controller. I will not speak a lot about program code. If you like the idea, I will create a set of lessons how to program each simple Internet of Things and how to program a controller. The idea is very simple. Here we create a Goldberg machine panel in IO control website. Here we put maximum temperature, and then we connect our microcontroller to local area network via Wi-Fi, and then we start in loop function checking lamp value, boiler value, and temperature value. Here we print all these values to monitor. So if temperature of water less than maximum of T, then they switch on lamp, and lamp is switched on, then this lamp must be switched off, and so on. So the algorithm is followed. Then the temperature is less than 24 degrees, lamp must be switched off. Now I will put the lamp to the initial state. Look at this, temperature, temperature is high when 22 degrees, and it's not good. Let's switch off the lamp. The lamp will be switched on, and the boiler is switched off too. Temperature is a little bit higher, and we must to recompile our sketch. Let's put the temperature to 20, for example, 4 degrees, okay? 24 degrees. So now I press here, and we must wait before my program compiles, and after compiling, my program code will be transmitted to microcontroller, and it will begin to work. So let's wait a little bit because it is not fast. So look at this. I don't know why, but my lamp is switched on. Let's check why it happens. Let's reload. Yes, see, someone from internet switched on my lamp. I suppose that it is someone of my students, or someone who listen this lesson online. So it is switched off. Look at this, and boiler is switched on. Why it happened? Let's understand. I suppose that program is transmitted to microcontroller. See this. Now controller works, and I think that boiler begins to increase value of the water. So see at these parameters. Boiler is switched on, lamp is switched off, temperature is 22 degrees, and now let's look to the picture, to the camera. Look at this. Here we see that the indicator is switched on. So it means that boiler is working. And look to the water. See, it works. And look to the temperature. What will happen with temperature? Is it increasing? I don't see that it. Yes. Oh yes. Look at the lamp. Lamp is switched on. It's a simple Goldberg machine. And look here. I mean, look to the boiler. Boiler is switched off because the temperature is higher than the maximum value. It is higher than T maximum. So it works. And the experiment is finished. And if you see to the water in the camera, the temperature is not increasing now. System is stopped. System will begin to increase temperature of the water. Then the temperature of water will be less than T maximum, and T maximum equals 24 degrees. So I suppose that I suppose and I hope that you understand the idea. The idea simply, the idea is the following. We have one thing, one boiler, one lamp, one thermometer, one some other device, servo motor or some other motor, and it must be connected to simple microcontroller. Microcontroller must be based on ESP32 microcontroller or ESP3266, or it can be based on Arduino microcontroller, Arduino UNO or Arduino Mega with Ethernet shield to connect your things to your local network and to transmit parameters to cloud web server. You can use or write your own cloud server. You can write your cloud server for controlling Internet of Things using MQTT protocol or Mosquito server. You also can write your controlling system using PHP or Python languages. And I want to create worldwide competition of simple Internet of Things. If you are interested in studying the way how to program Internet of Things, how they work with each other, how they transmit data from microcontroller to server or from server to microcontroller, you can write to my email and you can ask our colleagues from Russia Кружковое движение. You can write to my email and you can find me. The internet site is isobritarium.ru, and I can give a set of lessons of Internet of Things for all of you. Thank you for your interest, and I hope that we will soon more. Goodbye, Russia. We'll be glad to teach everybody. Hi, goodbye.